Today we're going to look at multiplying and dividing with our exponents. If I have b to the third times b to the fourth, that would mean I have 3b's multiplied together times 4b's multiplied together, which gives me a total of 7b's multiplied together. And 7 is how many of that base you have multiplied together. So notice, instead of having to write b 7 times, I can just add these exponents and I get 7. So when you multiply with the same base, you add their exponents. So that is our first property, our product property. So when you multiply, notice they have the same base. You're just going to add those two exponents. So that'll be m plus n. For example 2, if I have b to the sixth over b to the third, that means I have 6b's multiplied together on top. On bottom, I have 3 multiplied together. And so 3 of the ones in the denominator would cancel with 3 of the ones in the numerator, and that would leave me with 3 in the numerator still. So instead of having to write b several times, you can just subtract those exponents. So when you divide with two monomials with the same base, you subtract their exponents. So your quotient property, they have the same base, so I subtract my exponents, so m minus n. Let's look at an example. Numbers are still multiplied together. So 4 times 2 would give me 8. And I have a base x and a base x here. So they have the same base, so I can add those exponents. 3 plus 6 is 9. The numbers still get multiplied together. That negative is not an exponent in front of the 3, so it doesn't flip. It's just a negative 3, and you're multiplying it with an 8, and that gives you negative 24. I have an x to the 5th. The x over here, if I wanted to, I could write a 1 there, and I would add my exponents. So 5 plus 1 is 6. So I have 5 x's here, and then another x. That would give me a total of 6 x's multiplied together. Couple things you could do on this next one. I have the 7 here. They both have base x, so I can add the exponents. That would give me x squared. Or notice I could have done this as 7x to the 10th, and this x to the negative 8 would have flipped to the bottom. And in this case, if I'm dividing, I would subtract those exponents. And so that would give me 7x squared. So there's a couple different ways you could do that, and they'll both give you the correct answer as long as you're using your exponent properties. On the next one, I have 9. This is x squared and x to the negative 8. I think I'm just going to add those. And a negative 6 in the exponent means it flips. The 9 is not to that exponent, so it does not flip. And my final answer is 9x to the 6th. Next page. On example 4, I have division now. If they're the same base, you can subtract the exponents. So that's 14 minus 8. And that will give me x to the 6th. On example B, these are numbers. Make sure you're dividing numbers. You only subtract exponents if they have the same base. So these are numbers. People start subtracting numbers rather than dividing them. So make sure you're only subtracting your exponents. 21 divided by 7 is 3. And then this is going to be 12 minus 3, which is 9. On example C, 10 over 15, 5 goes into each of those, so I can divide 10 by 5 and I'll get 2. Divide 15 by 5 and I'll get 3. You could reduce that on your calculator as well. And then I'm going to subtract the exponents. So that's going to be 14 minus negative 7. And that will give me 21. Notice I could have also flipped this x to the negative 7 up to the top, and it would be a positive exponent then, so I'd have x to the 7th, and then I would add 14 and 7. On D, 3 over 9 reduces to 1/3. You can either subtract your exponents, well, that's what you probably want to do here. And so this is going to be x to the 2 minus 6. So that's x to the negative 4. And a negative exponent will flip to the bottom. Example 5. These are both in the denominator. I have a base g and another base g, so I can add those exponents. And a negative exponent then will flip to the top. So this is g to the 5th. An alternate way to do this is I could have flipped that g to the 8th, the negative 8 to the top, and it would be g to the 8th power over g to the 3rd. And then I could subtract these, and 8 minus 3 is 5. On the next one, I'm going to go ahead and add my a's together there. A to the 4th times a to the 5th gives me a to the 9th. You add your exponents. B to the 9th over a to the 7th, b squared. And now I subtract my exponents when they have the same base. So these are both base a, so I'm going to subtract 9 minus 7. And so I have a to the 2nd. And then b's have the same base there. So 9 minus 2 gives you 7. On example C, you can go ahead and subtract your exponents. That's one way. Or you could flip them if you wanted to flip them first. I think I'm just going to subtract. So this is 13 minus 8. Those have the same base. And my y's have the same base here. So I'll do negative 2 minus 8. So you do your number on top and you subtract the one in the denominator. So the one on top here was negative 2 and you subtract the exponent in your denominator. This becomes x to the 5th, y to the negative 10, and an exponent that has a negative on it will have to flip. So if it's on top, it flips to the bottom. If it's on bottom, it can flip to the top. Last example, I'm going to go ahead and subtract those. So these have the same base, so 7 minus 7. You always start with the exponent in the numerator and subtract the one in the denominator. And this will be q negative 3 minus 6. This is p to the 0 now. Q to the negative 9. Remember from yesterday's notes, p to the 0, anything to the 0 is 1. And the q to the negative 9 will flip to the bottom. And it'll be 1 over q to the positive 9. And if you notice here, p to the 7th over p to the 7th, those would just cancel. That would be 1. And that completes the notes.